Hey there. So in our previous class, we just created our project and put some small schema in place. But today we'll try to expand that a bit. First, we'll talk a bit about enums, but then add relationships between types. So we will create a director type. So a movie can have multiple directors, and one director can have multiple movies. We will define all of that in our schema first, and then we'll add persistence to our Java side using SpringGPA. I decided to go with H2 in-memory database. I just find it more suitable for development because we don't have to connect to any external databases or start Docker containers or just keep it simple. So our database starts with our app. I think that's it for some intro. Let me just show you here that you can access the code from our previous tutorial. So if you go to our website, SpringGraphQL tutorial, and we are doing class 2. And if you click here, you can just download the code from the previous class if you missed it. So you can just continue using this one. And I think that's it for now. Let's just start coding. This is where we left off in the previous class, and the first thing that I want to do here, let's just clean this up a bit because we don't need hello world anymore. And in this class, we will be expanding our schema. Let's talk first a bit about types available in GraphQL or in SDL. SDL, or Schema Definition Language, is a special syntax that we use to define our schema. So before going further, let's just repeat what we mentioned in our previous class in Introduction to GraphQL. So there are different types that we can use when defining our schema. The simplest one, obviously, is scalar types, which are leaf nodes that always resolve to a single value. GraphQL supports 5 built-in scalar types. So that were kind of integer numbers, floating point numbers, strings, booleans, and unique identifiers. The next one that we will use the most are object types. So these are our custom domain entities. So they are kind of objects that we model our POJOs on Java side. Enums are same as Java enums, so they are kind of fixed set of values. Lists are lists, and non-null types are guaranteed values, so we express them with an exclamation mark. The ones that we won't kind of go in deeper for now are interface types and unions. We'll cover that in the next lesson when we implement our search, because we will implement search across different object types. And we will cover input types in our mutations class because we used inputs to pass data into GraphQL. So the first thing, let's just add a rating here that will be type float, and let's define our first enum and call it genre. I won't be typing this. Let me just copy that from here. So we will change this from string to our enum. And let's define a new type. We'll call it person. And this type will have an ID of type ID that is mandatory, name of string that is mandatory as well, birth year, which is a whole number, and its optional because maybe they don't want to disclose it. And nationality, which is a string, and we'll leave it optional as well. And let's add directors to our movie. So a single movie can have multiple directors. And let's define that this way. So the reason I call this a person and didn't model a director, not directory, directors. I didn't model a director type is because a single person can be both a director and an actor. And I just didn't want to keep that separate because that means that we would need to keep all of these in two different places, and that's always a bad practice. So we will just link them this way. We'll do something different for actors, but we'll see that later. I think that's everything for our, and I actually see that I missed this, for our schema for this class. So in this class, we'll be adding a database to our app. So we'll be adding persistence layers. So let's first add those dependencies here. So I need a dependency of Spring Boot Started Data JPA. I need an H2 database. I just like working with H2 because that just means that we have our database made available immediately. We don't have to start some separate Docker containers or connect to an external database. I just find this really handy for development. And actually, for Spring 4, we need to include a separate dependency to make our H2 console available, and I'll add that as well. Let me just refresh this. And let's start updating our Java side. So let's first create a separate package for person and create our person Pojo. So we know immediately this will be a JPA entity. We'll add getters and setters to it. I actually like to have a builder as well. We'll add no arguments constructor and all arguments constructor. And we want an ID. So this looks correct. We want a name. We want an integer. No, we want an integer of birth year. And we want a string of nationality. I think this looks good. So the only other thing that I want to do here is I want to generate equals and hash code for this JPA entity. And actually for this, I have a template. I actually talk about that here. So if you go to this link, you can find Vlad's blog post about why this is a really good pattern. I won't go into it now. He explains it much better. So you can go here and read a bit about it. I actually have his book, and I think it's probably at this point in time the best JPA book available. So I just use this template for my JPA entities. And I think that's it. So if we go here, so actually here I use this Lombok data annotation. And this annotation gives us a lot of things. It gives us equals and hash code that we will be overriding here. And it gives us also a toString method with all of our fields. And so, often we do want that, but for JPA entities, that's usually a bad thing, because we mostly want JPA entities to be lazy loaded. And if we have a toString method with all fields, that might cause our JPA entity to be like to force load all fields. And that's usually not what we want. So instead of this, I'll be just defining getters and setters. So I want a getter and a setter, and I want to convert this into an entity, not equals hash code. I want an entity. So it's complaining that we need an ID. And let's just change this to our enum. So since I already know that we will be adding TV shows later, I'll be putting our enum into a shared package, because I want genre to be shared between movies and TV shows. So let's just go ahead and create it here. So you want genre enum, and again, I won't be typing this. I'll just copy it from here. This looks good. So let's just change this for genre. We'll need to mark this as enumerated. We'll need to add our rating, and let's add our directors. Private list of person that are directors. No, direct. And I'll actually initialize this array. I don't want this. And since we have a builder here and we are providing a default value, I just like to mark that as builder default, because without this, just compiler puts a warning. So obviously, a single movie can have multiple directors, and a single director can have multiple movies. So obviously, this is a many-to-many collection. And so usually I could leave JPA to generate a join table, because for many-to-many, we need a join table that will join IDs from a person or a director ID to a movie ID. But I just like having control over it. So I will be specifying it manually. So I'll just define a table name. No, I want join table. Join table. Name, and we'll call it movies. I need this in quotes. With the join column of a name, movie ID, and inverse join column of a join column name director ID. I think that's it for our movie. We just need equals and hash code, and again the same thing. And I think that's it. Let's just create our repositories. So I want a movie repository here. That will be an interface, and we will extend a JPA repository of movie, and our ID is long, so this looks good. Let's just create the same for our person. Repository, and we'll extend the JPA repository of a person and ID type long. So this looks good. And let's go to our controller. So we don't want the hard-coded values anymore. So let's use our final movie repository, and I'll just add required arguments constructor. So Lombok will generate a constructor for this. Since this will be the only constructor, Spring will inject these dependencies into that constructor. I just find this pattern nicer than having a constructor here. So obviously you can have a constructor if you prefer so. We don't need actually a person repository at this time. So let's just have a movie repository find all for all of our movies. And let's have movie repository find by ID of this ID and get. So I think this should be it. Let's actually no, yeah, we need data. Let's just create a package and call it config. And we'll create a class of data initializer. So yeah, again, I won't be typing this. So we'll just copy this from here. Everything loads correctly. Yeah, so at startup, this will be called, and it will just pre-populate our database for us. So it's just handy. So every time we start, the same data will be populated in. And I just find that really useful for some rapid development. Let's see if this compiles. And looks good. Let's try to refresh those. So bright. And I actually have a query ready here. Let's see if we can get our data. And yeah, so all data is available here. And obviously we can play around. We can, so if we go here, we can select everything or remove fields that we don't want. So the next thing that I would like to show you is we didn't actually change anything here. We didn't define our database URL. And the reason we can access all of the data is just because we followed conventions. So Spring is kind of predominantly convention over configuration. Obviously, you can configure everything, but if you follow certain conventions, it just gives you so much for free. But I do want to change few properties here because, again, just to have more control, because I like to access my database in the console. So let's just copy that from here as well. YAML. So I'll just take this application YAML and let me just add that here. So the only changes are we kind of defined some properties around data source. So we are explicitly saying that we want an in-memory database here. And we are saying that we want to keep the database alive for as long as JVM is running. We want to expose our console at this URL so we can access it through the browser. And we want to recreate the database every time we restart the app. Again, I find this useful for some quick development, because if we kind of change anything every time we restart the app, we'll just get our starting position. And again, I find that useful. So let's just see if this worked. So if I go here and I want to go to this, and this is again so bright. So let's just see, and we can connect. So the first time maybe you go to this URL, the JDBC URL might be a bit different. So by default, it just tries to point to your disk. So just be sure to change this to this value, and now we can connect, and we can see our 3 tables here. So we have all of our movies, we have our person table, and we have our join table. So this is very useful sometimes, just to see the raw data. And let's go here. I think that might be it. Now, actually, let's just show you one more thing. So obviously, you saw that we are getting our directors. And that's just because the movie entity has a join to the person table. So JPA fetches that data for us. We can kind of define that manually just so we can have more control. And actually, I want to show you what exactly happens. So let me define a list of person, and we'll doors, and I want a movie here, and we just return movie get directors, and we'll define this as a schema mapping. So you can see that our IDE immediately recognizes that this is a field in our schema. So this is kind of, you saw that it works without it. So obviously we don't need to specify this. Let me just restart to show you that it kind of works exactly the same way. And so if we go here and see that I can fetch this like exactly the same way. So nothing changed. What I wanted to show you is, let's just add some logs here. And I want to log info, fetching directors for a movie, and we'll just have the name here, title, get title. And what I want is, let's kind of slow this down a bit. And we'll add a 1 second delay here. just to see what happens. So if we try to fetch all of our directors now, we can see here what's happening, that for every movie, obviously we're doing a join on the person table. And for large sets of data, or if we were calling some external API here, we add a really big overhead here. Let's just check that, yeah, all of our data loaded. So this is called N+1 problem, and we will be talking about this a bit later. I just wanted to make you aware of it. I will actually remove this delay because I'll be pushing this class without it. And I think that's it for this class. So we will be, yeah, we'll continue in the next class. Next time, we will add cast domain model to our app. So we will be modeling actors who have different character names in different movies. So we'll do that through junction entities. We will also learn about nested resolver chains and understand how GraphQL resolves deeply nested queries. And we will add search to our API. That's it for this time. So see you in the next one.